Okay, here we have part 2 of our lesson, and we're moving on to our distance, rate, and time problems. So there's a similarity between distance, rate, and time and work, rate, and time. And I suspect you have heard of this relationship before, distance equals rate times time, or D equals RT. We often just abbreviate it like that. So notice that work equals rate times time and distance equals rate times time. So they're both the same idea. So let's take a look at number 3. A motorist traveling 55 miles per hour is being followed by a highway patrol car traveling 65 miles per hour. If the patrol car is 4 miles behind the motorist, how long will it take the patrol car to overtake the motorist? Okay, so we could draw ourselves a little picture of the situation. So we have the motorist. Oops. This is my car, sorry, kind of looks like a purse. And they're going a certain direction. And then we have the patrol car. This is going to be a little bit better. There we go. And they're 4 miles behind, but they're going to catch up. So this distance here is 4. And the question is, how long will it take to catch up? Okay. So what I like to do with any distance, rate, and time problem that has 2 different vehicles or 2 different people traveling or whatever it happens to be is I like to write down the distance, rate, and time for each of them. So we have the motorist and we have the patrol car, and for each we have a distance, a rate, and a time. So just setting it up like this. Notice I'm using the words, not the letters, because I want to reserve my use of letters for when I'm going to use variables. Okay. How far does the motorist travel? We're not actually told in the problem, so let's call this distance D. What rate is the motorist traveling? 55 miles per hour. How long is the motorist traveling? We don't actually know, so let's call that T. Okay, what distance is the patrol car traveling? Well, we know that would be 4 plus D. What rate is it going? We're told that's 65 miles per hour. And how long does this take? And they're traveling for the same amount of time. Maybe not for the entire length of the trip, but for the portion that we're interested in. Okay, so now we're going to set up a distance equals rate times time equation for both scenarios. So for the motorist, we have D equals 55T, distance equals rate times time. And for the patrol car, we have 4 plus D equals 65 times T, distance equals rate times time. We happen to have a system of equations here with 2 variables and 2 equations, and what we can do is just substitute 55t in for d in the second equation. So in a way, we're kind of previewing some of the things we'll be reviewing when we get to one of the chapters down the road. So we have 4 plus 55t equals 65t. Subtract 55t from both sides, and we have 4 equals 10t. And then divide both sides by 10. So t is 4/10, and let's change that to 2/5. And our units are hours, so we have 2/5 of an hour. Let's convert that into minutes. What would that be? 24 minutes? So it would take 24 minutes for the patrol car to catch up to the motorist. Now, is that answer reasonable? So how much faster is the patrol car going compared to the motorist? The patrol car is going 10 miles per hour faster, and it has to make up 4 miles. So 4 miles, 10 miles per hour. It makes sense that that would be 2/5 of an hour. Again, 4/10. 4 miles, 10 miles per hour. Okay, let's move on to the last example. Number 4, 2 ships are 120 miles apart and are sailing toward each other. If the rate of one ship is 4 miles per hour greater than the other, and if they meet in 3 hours, find the rate of each ship. Okay, so here we're going to draw a couple of ships. So just like my cars, I have great looking ships, and they're sailing toward each other. Ship 1, ship 2. So we're going to have a distance, rate, and time for ship 1 and a distance, rate, and time for ship 2. Okay. "120 miles apart, and one ship's rate is 4 miles per hour greater than the other. They meet in 3 hours, so we can fill in the times, 3 hours for both. Do they go the same distance? Do they each go 60 miles? No, because they're not going the same speed. So let's say that ship 1 is going at a rate of r miles per hour, and ship 2 is going at a rate of r plus 4 miles per hour. So I just made the decision that ship 2 would have the faster rate, but it doesn't tell us which one is faster, so you just have to decide. Now we don't know how far ship 1 is going, so let's say it goes a distance of d. So then how far does ship 2 go? Well, remember the total has to be 120, so if ship 1 goes d miles, then ship 2 goes 120 minus d miles. So we can fill those in, and then we can make our equation. So distance equals rate times time for ship 1, d equals 3r. Distance equals rate times time for ship 2, 120 minus d equals 3 times the quantity r plus 4. And we can go ahead and do a substitution. 3r gets substituted in for d. So we have 120 minus 3r equals 3r plus 12. So we can subtract 12 from both sides and add 3r to both sides and divide both sides by 6. Okay, I see I need to fix a little mistake there. 120 minus 12 is 108. Oops. And then divide by 6 and we get 18. So what is that telling us? That's telling us that ship 1 had a rate of 18 miles per hour. And then we know that ship 2's rate is 4 miles per hour greater, so ship 2 has a rate of 22 miles per hour. All right. Now what you're going to see in your homework is some problems that are variations, like maybe you're solving for time, maybe you're solving for rate, maybe you're solving for distance. So we keep the same concepts, but we kind of mix up how we approach the problems. So you're going to be doing a worksheet. It has, I believe, 6 problems on work and 6 problems on distance on the worksheet. Get it? Worksheet. Haha. And there's a PDF of it on Canvas. The answers are there as well. Remember that you can come back and ask questions either today or tomorrow during our beginning of the period time together. Don't forget to upload your notes and your homework and show your check and your corrections. Thank you, everybody.